Welcome to everybody. In this video we shall see in the Polytechnic TRB chemistry syllabus of unit 6 the photochemical reactions of the photochemical reactions part of video. We shall see these reactions. So mechanism of Norrish type 1, then Norrish type 2, Paterno-Buchki and Barton reactions, dipymethane rearrangement. So those reactions are given in the photochemical reactions topic. Okay, so in this video we will see about the Norrish type 1 and Norrish type 2 type of reactions. Okay, so initially Norrish type 1 reactions. Okay, so Norrish type 1 reactions. So we will beginning of starting this reactions of Norrish type 1. So initially we can conclude that what is the photochemical reactions. So the reaction is the generating of one reactant into the other product. So the catalyst of the photons, that is means that the photo in presence of light, the reactions is carried out. When the presence of light, the reaction is carried out, that is called a photochemical reactions. And thermal reactions also, in presence of thermal energy, then only the reactions is carried out, that is called thermal reactions. So this means that when the reactant is converted into product, that must be the need for the some activation energy. So the activation energy, and hence the reaction rate is fast. Okay, so therefore according to this rate of reactions and about telling about this concept, so the photochemical reactions is in presence of light radiations, the reactions is carried out. So especially the major part of the photochemical reactions is Norrish type 1, Norrish type 2 and like that, and remaining part that is nothing but pericycle reactions, so also the photochemical reactions. Okay, so their pericycle reactions also is given with as our syllabus. So there the electrocyclic sigmatropic event, photochemical addition and chelotropic reactions is like that is happen. So let's see the coming video. We will discuss about the pericycle reactions. So after this completion of the above mentioned the reactions of Norrish type 1, Norrish type 2 and then the Barton reaction, Paterno-Buchki reaction, dipymethane rearrangement. So those reactions when we complete, after we will discuss about that the pericycle reactions. Okay, so now let's see the Norrish type 1 reactions. So Norrish type 1 reactions is especially the Norrish type 1 reactions. It is a major product. It is a major product. It is a decarbonylation. Okay, so decarbonylation. So then second, the variety of products are formed. There is a variety of products are formed. So here, sorry, the pen is not working. Here the variety of products are formed. So when the variety of products are formed, but the major product, what is the major product? There is a decarbonylation. Okay, so then third point, it must be the alpha cleavage reaction. Okay, so the initial stage is alpha cleavage, then the delta hydrogen subtraction and the decarbonylation, dimerization and so like that the many step process is there. So dependence on the process we can get that different types of the products. Okay, so from those reactions we can get that the decarbonylation as a major product. So let's see that the reactions of or general reactions of CO or prime. So in presence of photochemical photons we can get that or then R prime plus CO. Okay, so there is a carbon monoxide is left out, we can get that alkane R we can get. So whether or it is a alkyne or arine. Okay, So dependence on the or we can get that such kind of the product is present. So see the benzophenone, phenyl, then phenyl. Okay, so in presence of a photon, so first step, what it happens, this goes to the N2 pi star transition. Okay, N2 pi star transition. So because the non-bonding electron of oxygen and the pi bond of the carbon oxygen bond orbital, okay, the pi bond of the carbon oxygen double bond, this goes to the migration, this goes to the transition is happened. So after this N2 pi star transition, we can get that the phenyl group, and C carbon means this carbon, then radical, here oxygen radical, then here it is a phenyl group. I think this one is not also working. Okay, so this type of the intermediate is formed. Okay, so this type of intermediate is formed. So this goes to the further, we can get that the phenyl acylinium ion, that means that phenyl, then C double bond O, sorry, so then this double bond O, then here it's radical plus phenyl radical. Okay, so then further this phenyl C double bond O radical, then it goes to the cleavage further happen, we can get that phenyl radical plus carbon monoxide. So this one of the carbon phenyl and this one of the phenyl radical, we can conclude that phenyl radical plus the phenyl radical, we can get that phenyl and phenyl. There is a biphenyl, product is formed. Okay, so whether the or in general reaction, here R is considered as a phenyl group, so then only we can get that this type of a product is formed. So in this case, we cannot get the other type of a product because we can not find out the alpha hydrogen or beta hydrogen and delta hydrogens like that. So nothing has happened. So only the decarbonylation is formed. So in competitive here, for example, in competitive here of a cyclic or in competitive here, for example, this cyclic compounds. For example, this cyclic compounds, the cyclohexanone. Okay, for example, this cyclohexanone is treated with a photon. What we can happen? This is alpha cleavage is happen for alpha cleavage. Okay, so this carbon has a radical and this has a free radical. Okay, so this has a free radical. So this is the first step. So this after we can number out, there is a alpha, beta, gamma, then delta. Okay, so this is a delta. So from this we can get that different types of a product. Okay, so now goes to the minus CO. Now goes to the minus CO means this bond is break. Okay, this bond is break, we can get that what is we can get what is the, so this is the after the decarbonylation or carbon monoxide, this is after left out this group, we can get that this intermediate. Okay, so then these two free radicals combine to each other to become a cyclopentane. Okay, so we can get that cyclopentane. So the cyclohexanone treated with photons in photochemical Norrish type I reaction, we can get that cyclopentane as one of the product. This is one of the product. Okay, so now let's go to this product, this intermediate. So now the delta hydrogen is subtracted. So this is the delta hydrogen. Okay, this is the delta hydrogen. So what it happens, this delta hydrogen is subtracted, we can get that unsaturated aldehyde is formed. Okay, we can get that unsaturated aldehyde. So here is a hydrogen, then it has the double bond. So why we can consider call it is about unsaturated? So it depends upon the carbon-carbon double bonds, whether the carbon-carbon double bond, triple bond, then only that is unsaturated. There is a saturated means there is a equally share of the carbon-carbon and carbon-hydrogen's bond is formed, but is not at all of the sigma bond. because one pi bond is additionally is present, so it's considered as unsaturated. Okay, so this product is also formed. So this product is also formed. Okay, so this is one of the product. So then further this goes to abstract here. Then we can explain another reactions detailing. So let's see, this gives a two type of product. Okay, so but here there is a more major product. It is a cyclopentane. Cyclopentane is a more product because we know that the Norrish type 1 is the major product. Is a decarbonylation or the elimination of the carbon monoxide. So wherever the carbonyl group of aldehyde or ketones that must be eliminated the carbon monoxides must be eliminated the carbon monoxide, the remaining carbon is directly linked with the sigma bond of the carbon to carbon atom. So now let's see the acetone. Now let's see the acetone as a reactant. Okay, so CH3. Now let's see the acetone as a reactant. That is at CH3, then double bond O, then CH3. Okay, so this goes to the alpha cleavage. We can get that CH3, then double bond O dot plus CH3. Okay, plus CH3 dot. So this further minus CO, we can get that CH3 dot plus CO. Okay, so this two CH3. So it's combined with the CH3 dot plus CH3 dot. We can get that CH3 bond CH3. Ethane as a product is formed. Okay, ethane as a product is formed. So then consider here there is the dimerization is also happened as a product. So from this information we can get that the different types of the variety of product is formed, but the major product, it is the Norrish type 1 reaction, is especially formed in the alpha cleavage of and followed by decarbonylation. So consider this cyclohexanone, it is a symmetrical ketone. Consider this cyclohexanone, it is a symmetrical ketone, but we can have the unsymmetrical ketone. This is the example of another. This is the unsymmetrical ketone. So here substitute one of the methyl group. So it's treated with the photon. So wherever the cleavage is happened, so whether this carbon-carbon bond and whether this carbon-carbon bond. So here competitive is the more stable free radical formation, intermediate, more stable free radical intermediate formation type of reactions is occurs. So for example, we can cleavage here. What is the intermediate here? There is double bond O. Then here is a free terminal or the primary free radical is formed. Okay, here is the primary free radical is formed. So the primary free radical is less stable compared than the secondary than tertiary. So it's the directly proportional of the carbocation intermediate. That means that the similar behavior of the carbocation and the free radicals. The free radicals of primary there is a less stable secondary than the tertiary free radicals. So tertiary free radicals are more stable compared than the secondary than the primary. Okay, so for example, another one of side, this side is CC bond is break. We can get that double bond O, then free radical, then here methyl substituted carbon has one of the free radical. Okay, so this carbon it has a secondary. This carbon it has a secondary carbon. So secondary free radicals, so it is a more stable. Okay, so the favor of the alpha cleavage. So here the favor of the alpha cleavage. This side is happened. The favor of alpha cleavage, this side is happened. So after the decarbonylation, we can get that the substituted cyclopentanone. Okay, substituted cyclopentanone as a product. Okay, done. We will see about the Norrish type 2 reaction. Norrish type 2 reaction. So Norrish type 2 reaction is a the Norrish type 2 reaction is nothing but it's a photochemical reactions similar to the Norrish type 1, but slightly different from the Norrish type 1 reaction. It's a beta cleavage is occurs. Okay, so first of all the alpha cleavage, then followed first of all, for example N2 pi star transition is happen. For example, see here there is a R double bond O and alpha, beta, gamma. Okay, so then this is the alpha, this is beta, then delta. Okay, alpha, beta, gamma, then delta. So this has the hydrogen bond. Okay, this has the 3 hydrogen. So now it goes to the initially the N2 pi star transitions happened. N2 pi star transitions happened. Here is a R, then double bond, sorry, here O dot and here C dot. Then 1, 2, 3, 4 carbon. 1, 2, 3, then 4. Okay. So this is 1, 2, 3, 4 carbon. 1, 2, 3, 4. 1, 2, 3, 4, and then 5. This is not at all. So alpha, beta, alpha, beta, alpha, beta. This means that beta cleavage means here is occurs. Okay. So not at all. This gamma hydrogen is subtracted. Sorry. So Norrish type 2 reactions, the gamma hydrogen is subtracted. Here is a hydrogen. Here it's one of the hydrogens. I can conveniently write here. So it's CH3. So this goes to attack here. Okay. So we can get that a 6-membered transition state is formed. Okay. A 6-membered transition state is formed. So now this goes to here. Okay. So then this goes to here. Then this goes to here. Then this comes to here. Then this goes to here. So we can finally get R OH and double bond plus here it is a double bond CH3. Okay. So now this is the enol R, then OH double bond. This is the enol is the more stable than ketone. Okay, enol is the more stable than CH3. Enol is the more stable than ketone. Okay, so from this information, the Norrish type 2 reactions is the gamma hydrogen subtraction followed by beta cleavage. Gamma hydrogen subtract by beta cleavage. That is a Norrish type 2 reactions. Okay, that is a Norrish type 2 reactions. For example, then R here double bond, then alpha, beta, then gamma. Okay, we can get that this type of product reactant. Okay, this goes to the photochemical reactions. So now see, here it's a hydrogen. Okay, so then R O dot, then carbonyl carbon dot, oxygen dot. Okay, so then here, then here. Okay, so here is a hydrogen, here is a hydrogen. So this bond comes to here, this electron goes to here, this comes to here, then this comes to here. What we can get? There is a R dot here. It's a OH. Okay, so then R dot here OH. Then this goes to here. There is a cyclopropane radical. Okay, this is. Then further this comes to here. Okay, then this then further this comes to this. Then further what it happens, this further this comes to here, then this bond is, then this bond is break to here. This is alpha beta. Okay, so this bond is break, and then this bond comes to here. Okay, so now this free radical and this free radical, this formed the pi bond. So we can get that R, then OH double bond. Okay, this carbon, this is this carbon, then this. Okay, this carbon. Here is the one of the free radical, and here one of the free radical. Okay, so this bond, this electron comes to here, this electron comes to here. Okay, so then this free radical and this free radical combine to each other, we can get that R OH double bond, then double bond. Okay, this is a enol, this is a enol as a product. Then enol is less stable compared than the ketone, so we can get that R double bond O. So it's a product. This is an unsaturated ketone as a product. Okay, so from this we can conclude that the Norrish type 1, it is the alpha cleavage, decarbonylation is occurs, some major product, and the cleavage is the most stable free radicals formation is occurs, and the Norrish type 2 is enhance the rate of reactions in presence of photons light or intensity of light. Then the Norrish type 2 reactions is the gamma hydrogen subtraction and beta cleavage occurs. Okay, gamma hydrogen subtraction and beta cleavage occurs. Okay, thank you friends. If you have any doubt in this Norrish type 1, Norrish type 2 reactions, you can comment with me. I can clarify the questions. Please subscribe, don't forget about like, share with your friends. Okay, thank you to all.